So I thought this was a interesting problem in this section, just because they did it a way that I wouldn't think about doing it, but um, it's just a nice way to see how, again, you can use that theorem we just did about expected values to break up expected value of the sum as the sum of the expected values, and it works out nicely in this case. So here's the story. Dr. Windler, okay, I don't know what he is. Maybe he's a dentist. Anyway, his secretary accidentally throws a patient's file into the waste paper basket. And a few minutes later, the janitor cleans the clinic and dumps the waste paper baskets containing the file into one of 7 garbage cans outside the clinic. So, she threw it inside, and then outside, let's say there are, we'll just make these, here's 7 garbage cans, so we'll call this 1, 2, 3. So it could be in any one of these, right? They dump it randomly, and it could equally likely go into any of these garbage cans. On average, what's the expected number of cans we're going to have to check to find the file? And if you've ever lost a retainer, the ones that go in your mouth or anything like that, how you've probably done some dumpster diving. I can tell you in my college days, I lost a few things that I dumpster dived for, and one of them was a mouth guard, right? Ooh, okay, I can't really, doesn't look really good, but you stick these things in your mouth, you get them at the dentist, and they're very expensive. So I finally figured out one day it went into one of these garbage cans, and I went diving, and I found it. It wasn't my proudest moment, but anyway, it's in one of these garbage cans. So it's kind of tricky. So let X be the number of garbage cans that Dr. Windler should empty to find the patient's file. So X could be 1, 2, 3, 4, 5, 6, 7. And again, we could build a big distribution, but I'm going to do it a little bit differently. So let's just define like a Bernoulli random variable. So what's going to happen is really X is a yes or no. If the so let xi equal 1 if the patient's files in the, or xi equal 1 if the patient's files in the ith garbage can. So for example, x2 or any of them, the probability that let's just say x2 equals x, it either takes on the value 0 or 1. And the probability it takes on 1 is it's in there, and there's only a, sorry, I shouldn't have written it like this. X takes on the value 0 or X takes on the value 1. The probability it takes on the value 1 is 1/7. I mean, the probability it's in x2 is only a 7th, and the other is 6/7. Okay, and maybe I don't even need to say this part, but underlying there is like a Bernoulli going on with each one of these. So I want X to take on the value. So, if I find it in the first garbage can, I want X should take on the value 1, because X is the number of garbage cans he has to go through. If he finds it in the fifth, I want it to take on the number 5, right? So if Xi is equal to 1, if it's in there, the only way I can make it take on that value is if I multiply by the constant ahead of it. So here's what I'm going to do. I'm going to say this is 1 times x1 plus 2 times x2 plus 7 times x7. Does this make sense? So all of these, well, they're either going to take on the value 0 or 1. So imagine that he found it in the 5th garbage can, and the 5th garbage can in here is going to take on the value 1. All these other x's are 0, so I'm going to have a 5 times x1, which is 1, and x will take on the value 5 then. So I'm going to let x equal the sum of these random variables. And so what we just said by the last on the last video or the last page, that's expected value of 1 times x1 plus 2 times x2 plus 3 times x3 plus 7 times x7. So this is 1 times expected value of x1 plus 2 times expected value of x2 plus 3 times expected value of x3 plus 7 times expected value of x7. So 1 times, well, what's the expected value of any of these guys? Well, expected value is p of x times x, right? So 1/7 times 1 plus 6/7 times 0, that's 1/7. So 1 times 1/7. X2 has the same format, so its expected value is 1/7. So all the way down here to 7 times 1/7. So I should be able to add these, right? This is just the sum of 1 plus 2 plus up to 7 divided by 7. So what is that really fast? Right, there's a nice, right? N plus 1 times n plus 1 times n over 2. I don't know, let's just 1 plus 2 is 3, 3 is 6, 4 is 10, 5 is 15, 6 is 21, so this is 28 over 7, which is actually equal to 4. So on average, he's going to have to look through 4 garbage cans before he finds the file that's missing. So I thought that was kind of interesting, right? I mean, would you have thought to do the problem this way? I mean, that's not my first thought. I probably would have, said the probability found it in 1 is this, 2 is this, 3 is that, and not made this random variable here. But it certainly makes the problem quite easy then. So I'll do a few more and then sign off.